Hello guys, welcome to XMaths tutorials. In this video we are doing inverse of a 3 by 3 matrix. So let us see the steps that we have to follow in order for us to get inverse of our 3 by 3 matrix. So in this case we have an example that I want us to use, which reads: determine the inverse of matrix A if A is 2, 4, 2, 1, 2, 2 and 1, 1, 1. So the first step that we have to do is to determine the determinant of the matrix. But before going to a determinant, we have what we call the matrix of minus, which is plus, minus, plus, then minus, plus, minus, then plus, minus, plus. This is what we call matrix of minus of a 3 by 3 matrix. It follows the order. We have 3 rows and 3 columns. The 3 by 3 part comes from 3 rows and 3 columns. So that's why we are saying it's a 3 by 3 matrix. So the matrix of minus is like this. It's just the signs: plus, minus, plus, minus, plus, minus. To determine the determinant of a 3 by 3 matrix, we only need one row. We don't need all those 3 rows. So in this case we are going to use the first row, which means on our matrix here, matrix A, we are going to use 2, 4, 2 row. So let us calculate it. For determinant, we have a 2. A 2 is plus. It corresponds with the plus on our matrix of minus. So that's going to be plus 2. Then you open these 2 bars. So you close this and this. So you close the column of 2 and its row. What is left here, you write it down here. So we have 2, 2, 1, 1. Then the number that follows is a 4, but a 4 on the matrix of minus, it goes with it has a minus sign, so we're going to say minus 4. Then you close the row of 4 and its column. You have 1, 2, 1, 1. Then we go to 2. 2 goes with a plus sign, so there's going to be plus 2. Then we close the row of 2 and its column. Then we'll be left with 1, 2, 1, 1. So you can see that we have formed 2 by 2 matrices. So 2 by 2 matrices are in the general form A, B, C, D. So when you are determining the determinant of a 2 by 2 matrix, I hope you know how to determine the determinant of a 2 by 2. If you don't know how to do it, you can check on my videos. Determinant, you say AD minus BC, which means A multiplies D, subtract B multiplied by C. So in this case, let's take the first part. Our A is 2, our B is 2, our C is 1, our D is 1. So that's going to be 2 multiplied by AD, which is 2 times 1, we get a 2. Then 1 times 2, we get a 2 as well. So that's 2 minus 2, it's a 0. Then minus 4. 1 times 1, it's a 1. Then 1 times 2, it's a 2. So that's 1 minus 2, we get minus 1. Then plus a 2. Then 1 times 1, 1. 1 times 2, 2. That's 1 minus 2, we get minus 1. 2 times 0, that's a 0. Then 4 times 1, minus 4 times minus 1, that's a 4. Then minus 2, we get a 2. So our determinant is 2. That was our first step for calculating determinant. Then step number 2, we go to matrix of minus now in full. We have to consider everything here. So to determine your matrix of minus, you simply have to form your 2 by 2 matrices. So they should be inside here. Then also here and here. So our matrices will be here and here, here and there. So we check now the sign of our matrix of minus. For the first one is for this block as a positive sign, the second one is a negative, and the third one is a positive. Then here we have minus, plus, minus, then plus, minus, plus, then we just have to fill in our values inside there. So what we do, we did the same thing for the first part. We close the row and column of 2. We have 2 2 1 1. Next one, we close the row of 4 and its column. So we have 1 2 1 1. Then we go to the last one. You close the row or the column of 2 and its row. So that's going to be 1 2 1 1. Then we go to the first value on the second row, which is the 1, this one. So we close the row and column. We have 4 2 1 1. Then we go to this central value, which is a 2. We close its row and column. We have 2 2 1 1. We have 2. We're going to have that is going to give us 2 4 1 1. Last row, we close that first one. We have 4 2 2 2. Then we go to the second one for this row. We close its row and its column. We have 2 2 1 2. Lastly is the last one there. We close its row and the column. We have 2 4 1 2. So when determining the matrix of minus, don't do as what we did here on determinant, writing down this value like these 2. In matrix of minus, you do not need to write a 2 here, a 4 or any value. You just need the matrix of minus, the signs only. You only need to write that value here when you are looking for a determinant. Let's continue. So to simplify that one, we simply have to find our AD minus BC. AD minus BC. Get the values. Okay, let's see what we get. First one, that's 2 minus 2, we get a 0. Then 1 minus 2, we get minus 1. Then minus 1 times this minus, we get a positive 1. Then 1 minus 2, we get minus 1. Then we go to this one, that's 4 minus 2, because 4 times 1 is a 4, 1 times 2 is a 2. So 4 minus 2, we get a 2, times this negative sign, it becomes minus 2. Then we go to this part, 2 minus 2, we get a 0. Then 2 minus 4, we get minus 2. Minus 2 times a minus, we get a positive 2. Then we go to the last row. We have 4 times 2, 2 times 2, that's 8 minus 4, we get a 4. Then 2 times 2, that's a 4. 1 times 2, that's a 2. So 4 minus 2, we get a 2. Times this minus sign, we get minus 2. Then we have 2 times 2, 4. 4 minus 4, that's a 0. So what we have formed here is a mixture of matrix of minus and the 2 by 2 matrix. So a combination of these two form what we call matrix of cofactors. So this is what we call matrix of cofactors, because there is minus plus our 2 by 2 matrix is simplified already. The third step, we do what we call the adjoint. So to determine the adjoint, you exchange the rows being the columns. So which means this row becomes the first column, and this row becomes the second column, and the last row becomes the last column. So 0 1 minus 1 is now a column. 0 1 minus 1. Then the next column is minus 2 0 2. Then lastly 4 minus 2 0. 4 minus 2 0. This is our adjoint. Then lastly, step number 4, it's our inverse. So our inverse is equal to 1 over your determinant multiplied by the adjoint. Finally, the inverse of a will be equal to 1 over determinant, our determinant which is 2, then our adjoint 0 minus 2, 4, 1, 0 minus 2, and minus 1, 2, 0. This is our inverse. Some may choose to distribute this half inside this bracket. That will simplify to half times 0, we get a 0. Half times minus 2, we get minus 1. Half times 4, that's a 2. Then half times 1, we get a half. Then half times 0, that's a 0. Half times minus 2, we get minus 1. Half times minus 1, we get minus half. Then half times a 2, that's a 1. Half times 0, that's a 0. It's not a must to expand it like this. Even if you leave your answer like this, it's still okay. But if the question is asking you to expand it, then it's okay. You need to simplify it further. Thank you guys for watching this video. Don't forget to subscribe, like, and share.